And then going to part B. Part B says that we are given a complex number, a half, I minus a half. So we start by saying let Z be that complex number, a half, I minus a half. And then we find the magnitude of this complex number. So we shall say R equals to the square root of x squared. X is negative half squared plus y is a half squared. That means here we shall have the square root of half squared plus half squared is half. Half squared 1 divided by 2 squared is 0.25 plus 0.25 get 0.5. So here it gives us a half or 0.5. That is same. What is the square root of a half? It is 0.7071 units. This is the value of R. Let me confirm. 0.5 squared times 2 under root. Yes. So this is the value of R. Let us find the value of theta, which is the angle. This is the imaginary axis of Z. This is the real axis of Z. That is the origin. We have a half and a half. So they are equal in magnitude. So I can just put here a half and I put here negative a half. Also here a half and negative a half. Approximately equidistant from the center. And then we represent the real part is negative half, which is here. The imaginary part is positive half, which is up. So we shall have this vertically straight, and then this horizontally straight. This is where they are meeting. That is the point of intersection. So we draw a straight line from the origin up to where the complex number is, with an arrow on top. And then we have said this is my complex number that you have called Z. Or you can simply mark it with the same values that are given there. Now, where is the argument? The argument is the angle from the real axis, from the positive real axis up to where the complex number is. What do we see here already? We know that this angle is a right angle. So this one gives us here 90 degrees. So we are left with finding this small angle so that we add it 90 and it gives us the argument. Now, from here up to here is negative half. That means here we have half units. That means from here up to here is the same as from here up to here. So this side is half. Then from here up here is also a half. Please extract the triangle. I have extracted so many triangles when we are doing the argument of the complex number. So from here, it is your task. So I'm going to see the triangle from there. I'm going to apply tan. Let me call this angle that we don't know here maybe beta. That angle beta. So that we now say tan of the angle beta is given by the opposite. This is the angle. Opposite to the angle is this length here, which is a half. Half out of adjacent to the angle. Adjacent is this length from here to here, which is also a half. So out of a half. So tan of beta equals to what is half divided by half? It is 1 because you are dividing a number by itself. 0.5 divided by 0.5, yes, it is 1. That means now beta becomes the tan inverse of 1, or simply arctan of 1. So you just press the calculator, press shift and tan, it gives you tan inverse of 1, which is 45 degrees. This is just that small angle. Therefore, now our theta, which is the argument, now becomes 90 degrees plus the small angle that we obtained, 45 degrees. This here gives us 135 degrees. This is the argument. Then you come to the polar form, because we know that from the polar form is r into the cosine of angle theta adjuvant plus I sine of theta adjuvant. This means that what is the value of r? 0.7071. Yes, into cosine of the angle 135 degrees plus I sine of the same angle 135 degrees. This is the answer for the polar form. Or you can use the other form and say z is given by r comma theta. This means that our r is 0.7071 comma, what is our angle? It is 135 degrees. This is also correct. Choose one. So this is the solution to example to part B. Let us go to part C.